first speaker for this afternoon is Macklin, who is a principal engineer at WeMoney. He brings together crystal clear objectives, culture of support, streamlined operations, and adaptable technology. He's a firm believer in small dynamic teams that embrace autonomy and take responsibility, prioritising outcomes over specific solutions. Very important, he's from Perth. Go Perth. He's also a mentor at SheCodes Plus, but today he's talking to us about performance, which is really, really critical. If your site is not fast enough, I will find you, or Macklin maybe will as well. At this point, we'll hand over to Macklin.
Thanks, mate. All right, so I'm here to ask the question that's on the screen here. How fast is your website really? So yeah, before we start, this is me. Like it has been said, I'm from Perth. There's a joke in here about how at every conference, every DDD in Perth, as well as all over the place, there's a bunch of people that come here from Perth. We like to roll deep. So you might have seen Amy's talk this morning, or there's one after my one actually that's really, really good. It's worth going to. Should fill the room with that one. It's an interactive talk about cybersecurity by two people called James. But yeah, there's always lots of us here. This is me. So a little bit about what I'm going to be talking about today. Spoiler alert, it's about user-centric performance. I'll explain that in a minute. It's about how to capture metrics from end-user devices, and it's how to do that with continuous monitoring. What's not in this talk, so this is your opportunity to leave if you were kind of expecting this, is web performance improvement. I think that's probably a different talk entirely. Like, invite me back here next year, I'll talk about that. But I'm going to focus on how to track web performance, but not how to improve it. If you want to see that one, yeah, vote for my talk next year and I'll come back. So let's start out. I like to start out by, when I'm exploring any topic, by forgetting everything I might, all my assumptions, everything I might know, go a bit smooth brain and just go, what's the most naive approach that I could start with? And then we'll work up from there. So if I was going to track web performance in a really naive and simple way, I might do something like this. Here's like 4 lines of code, really, even less. What you might do is you might take a timestamp of as early as you can when your page is loading, as soon as you can when your JavaScript starts running. And then add an event listener for this particular event here called just load, nice and simple. Track the difference between those 2 timestamps and that would give you the page load time, right? But there's some problems with this. If I take a really good look at the performance inspector, the issue with this is you can see, hopefully, there's this red line here. That's when the page actually loaded. And the issue is there's stuff on either side of that. So it's not actually telling you when the page loaded. And the reason this happens is because modern frameworks, these JavaScript forward frameworks, the page, the way it used to work, I guess, on the web is your page would load and it would finish. But the way these modern frameworks work is there's stuff happening on either side of that, particularly on the right side of that, which is kind of a problem. Your page doesn't finish loading when this event comes in. So what do we do about that? One thing we might do is have a look at this new navigation timing API. It's more of a sort of a recent API. It gives you much more detail into the events that are happening when your page is loading. But I don't know, I don't think this is really good because there's a lot of words here. Like, how do I know the difference between domain lookup end and load event start? Like, what do those 2 things mean? And yeah, it's just a bunch of numbers. This isn't particularly useful, I don't think. So this is where the W3C Web Performance Working Group comes in. This is a group that was founded to kind of solve this problem, to try and figure out how we could improve performance on the web and make sure that performance is kind of meets expectations. You can see there's a lot of big names down there. There's representatives from all of these companies working in the Web Performance Working Group. So there's quite a lot of attention on this, you can imagine. And this group has come up with a thing called user-centric performance. So what does that mean? Well, they've kind of split it into 5 different things. They've got 5 focus areas. They've got perceived load speed, load responsiveness, which is how quickly your website takes to load, those first two. And then runtime responsiveness, so once the page has loaded, after that, how responsive is that website after that point. Then you've got visual stability and smoothness, which really center around if you've got animations on the website. It's a really good example of that. Are those animations smooth, or are you kind of getting jaggedness and not an ideal result there? And they've translated these focus areas into a bunch of metrics. These are the metrics here. Put your hand up if you've heard of these before. Cool, so quite a few people, but that's good. That means I can go through and explain each of these and give you a bit of an understanding. Yeah, and the other thing is you're going to see these abbreviations a lot, just because it's a lot easier to say those couple of letters than these full words here. So I'll explain all of these, but don't worry if those abbreviations start to I guess merge a little bit when you hear them. So first one I'm going to talk about is time to first byte, and basically this is the time between when the browser requests the page, so you go to google.com, and then the first byte of information coming back from the server. Essentially, it's kind of all of this stuff that happens in the background when you're loading a page. You don't just make one request to the page and then it gives you the page back. There's actually quite a bit of a dance that happens. And then that response, that last line, is generally when you start seeing the page loading. Obviously, all this happens quite quickly, but when we're talking about web performance, we're talking about quite a short time frame and trying to improve that. And the Web Performance Working Group says that when you're tracking this metric, a good value for this metric is something under 800 milliseconds, and anything over 1.8 seconds is sort of a target for improvement. Next up, we have first contentful paint. So this is the time from when the page starts loading. So once you have that time to first byte, after that point, how long does it take for anything on that screen to start rendering? So from when you're kind of recording that time to first byte, your page is probably still a blank page, still a white page, because you've just got that data back. Now we're talking about rendering that data onto the screen. And this is a metric that captures the moment the first element is actually rendered. So I use Google as an example here because they stream the results back. So you tend to get parts of the page as it loads. I've slowed that down obviously, but you can see that top part, which is your search result, will load first, and then you'll get the rest of it. So the FCP metric is that the moment that first block on the page renders. The working group says that a result of under 1.8 seconds, I guess on average, is good, and anything over 3 seconds is also room for improvement. Next up we have largest contentful paint. So this one's a little bit trickier in terms of how they actually calculate this, but this is tracking how many seconds it takes for your most data intensive above the fold element to load. So this will be something like on a news article, probably either the image or the content itself, the title of the article, the thing that I guess would draw the most attention to your eye. How long does that take to load? So going back to the original example here, you can see that the largest contentful paint, we're tracking that as it goes down the page. It's actually debatable whether it's that video trailer in the middle or it's the content of the search result below, but it'll be tracking, I guess, the largest thing on the screen, and that's when that metric's actually recorded. So for this one, the working group says that ideally this is under 2.5 seconds, and anything over 4 seconds is too long, needs improvement. The next one we've got is first input delay. So this is the time from when a user interacts with the page to when the browser is actually able to begin processing of the event handlers and when it renders the outcome of that action. This one's a little bit trickier to visualize. I did this really simple example to show that. And you might have seen this sometimes when you're using a web page. If you click on something, there's a little bit of a delay before something happens. Generally, something like this might be the result of some sort of network request needing to come back so you could see the result. And the way you might combat that is change the layout of that button so it has a loading spinner or something like that, so you at least know that the page has done something and it's responsive. First input delay, you generally want that metric to be much, much lower. So anything under 100 milliseconds is good. That's generally the, I guess, the uncanny valley of when you get that instantaneous response. It's usually something under 100 milliseconds, not actually instantaneous, but under 100 milliseconds is not noticeable at all. Anything over 300 milliseconds, and then your users will start to notice that, so that's not a good experience. And that's room for improvement there. Next up is interaction to next paint. So this is actually a bit of a newer metric. I've done this talk over a couple of years. I started this one in Perth and did it in Brisbane, and since then I've had to add this slide because it's a newer metric. This represents basically what we're tracking with first input delay. The first input delay is actually only tracked on the first click on the page for specific reasons. And interaction to next paint's calculated a little bit differently, but it's tracking your responsiveness over the entire usage of everything on your site. So here's a good example. Obviously we're interacting with this accordion multiple times. And you can see on the left an example of poor responsiveness where there's a delay there, so we're not really sure if we've intercepted that action, and then the user clicks it again and then it bounces up and down, which is not really good. You can see on the right that's a much better experience. Interaction to next paint, anything under 200 milliseconds is good, and anything over half a second is probably too much. The last one that I want to talk about is cumulative layout shift, CLS, and it's a calculated score, so we're not going to talk about milliseconds or anything here. It's a calculated score between 0 and 1 for any unexpected layout shift that occurs on the page. So what does that mean? I'll obviously visualize this one again as well. It's when you get stuff like this. I hate these things. Usually it's a consent banner. Unfortunately, you have to have those. That's kind of annoying. But you know, here's an example of one that wasn't really necessary and it kind of ruined the user experience. Here's probably one where I guess the result is a little bit more severe. You wouldn't want something to happen like this. I think this is actually something that did happen once, so yeah, not ideal. Try and avoid this if you can. The working group says that anything under 0.1 is good. It's a little bit hard to know what this is going to be without tracking it, because it's sort of a magic number. But yeah, anything under 0.1 is good. Anything over 0.25, you can maybe read that as 25%. That's probably bad and needs improvement. Cool, so I want to talk a little bit about these because these metrics have become increasingly important. And you go, why would I actually care about what these metrics are? You can actually tie this to a benefit to, like, if you kind of work in the web. I guess you know, you want your site to be as responsive as possible, because this actually affects how your how sites like Google, I guess, rank your site in terms of the results. If someone searches for WeMoney, for example, if our website's performing slowly, we actually might get outranked by our competitor because of that. And I want to focus on the top three there, because the signals that actually make up how Google ranks your site when it appears in search results, 3 of those are core web vitals. So just those metrics that I told you about before. On top of that, they also track whether or not your site is mobile friendly, if it's secure, and doesn't have intrusive interstitials, which is pop-ups, the traditional kind of pop-ups. I will say as well that Google will never tell you how much this impacts your search results, but I think potentially the impact of this is a lot larger than people realize. I think the kind of people who sell SEO kind of magic solutions to problems, and it's all add a number of blog posts and all that sort of stuff, probably unaware of this kind of stuff, whether the performance of the site actually matters. And this is probably where you can kind of outcompete them, I think, a little bit. I wanted to clarify something as well. So I think I mentioned it before, but the time to first byte first contentful paint and largest contentful paint metrics are atomic. So your time to first byte is always going to be a smaller number than first contentful paint and largest contentful paint because they're tracked as the page loads. So looking at that, hey, only 3 of those core web vitals are, those 3 user-centric metrics are in here, but largest contentful paint actually includes first contentful paint and time to first byte. So it's important to track all of those 3. And here we can see a case of where we're actually tracking these and improving these metrics, if you can do that, can yield a better result. So in Vodafone's case, they improved LCP by 31% and it increased sales. Vodafone's a large company, so if you could, I guess you're coming to a conference, if you were able to go back to work on Monday and convince someone of something, case studies like this, case studies of this sort of thing that you can take to your leaders and in your workplace and say, hey, look, if we're able to kind of focus on some of this stuff, we could return a good yield in some way. Cool, so we know a little bit about user-centric performance, that's good. Now, I guess what we need to figure out is how do we actually capture these metrics? How are these generated? How do we figure out what our LCP is, for example? There's a couple of ways you can do that. You can use ad hoc testing, or synthetic monitoring, or real user monitoring. So I'll cover what each of those mean. Starting with ad hoc testing, who's used Lighthouse before? Yep, cool, that's most people. Lighthouse will actually, you can open up any Chrome browser if you've got it on your computer, and you can, actually any Blink-based browser, so you can do this in Edge, I think. And you can run a test on any site you want as well. So I can go and do a test on google.com right now and give you a result here. And yeah, this report will sort of give you a report of not only what your scores are. This one's nice because it'll tell you some quick areas where you might be able to improve that score. It's built into every Google Chrome browser, so that's nice and handy. If you don't use Google Chrome for certain reasons, or if you wanted to test in some different ways, this is another option as well. So what this does is it runs a Lighthouse test in a data center on a Motorola G4 or something like that in the US. So that's nice because now you're actually testing in Lighthouse on a mobile device. So that would give you probably a better representation of what your traffic is like. Most people aren't sort of browsing on a $6,000 MacBook. They're on their phone. These are both really good because in both cases they're free. Google Chrome's free, that tool is free. But there's a bit of a downside in that they're once-off manual tests only. I can't automate this. I can't run a script to automate this. And they're also unlikely to represent real-world traffic. So running this on my computer, most people aren't going to be using a computer like this. Same goes for the device in a data center. That data center is going to be in the United States. So if your customer base is primarily based in Australia, for example, you might not actually get the result that best represents real-world traffic for you. So another option you've got is synthetic monitoring. So this is a tool that's actually built in Melbourne. I don't know, maybe some of the people are here today who built this. It's called Calibre. I think their really good trick is they're able to, in a pull request, they have some automation set up, so they're able to run a Lighthouse test each time you open a pull request and give you a really useful report to tell you, I guess, whether or not the change that you're about to make is going to impact your performance. So that's really cool. It tells you all sorts of details about a given individual change. They can also run tests on a regular basis. So if you're not actually making a change, you can have a test run once a day just to see if there's any sort of change happening. So this is good. We can have continuous delivery and we can have scheduled automation. We can be testing this continuously. We can monitor change over time. So they keep a record of your performance over years and months. Sorry about this. They keep a record of your performance over years and months, so you can see if there's any sort of trends over time, whether or not you're getting better or worse. That's always helpful. This one, in this case, is not free, although they're pretty competitively priced, I think. The team that builds this are sort of not the team, not sort of people who are going to price gouge or anything like that. It's a small team. But it's also still not representative of real-world traffic. So they do have a few more options in terms of the kinds of devices and the locations of the devices they can test on, but they're not real-world devices. So I've said that twice now, right? Not representative of real-world traffic. That must be pretty important, right? I'm kind of stressing that point. And it is really important. If we were to naively look at the global market share for operating systems, devices, you might be mistaken in thinking that it's fairly homogeneous. There's really only iOS and Android. You got a tiny sliver. I don't even know what that is anymore. iOS and Android. That's pretty much. You only have to test for iOS and Android, right? Don't have to worry too much about that. Same with the browser you might be using. 64% Chrome, 19% Safari, but also that's Chrome, that's Chrome, that's Chrome. So it's mostly Chrome, right? So yeah, there's 2 browsers and 2 devices that you have to do 4 tests, right? It's actually 3. But that's probably not telling the full story, because if you look at the performance of low-end devices versus high-end devices, so something like a Moto E13, which is a fairly new device, versus the latest Apple iPhone, the difference in that performance is quite staggering. Like, I'll look at a sort of another example here that you can see the difference sort of plotted over time. Sorry about this screen. I don't know what's going on here. On the one hand, I look at this and I'm extremely impressed. Like, the nerd in me goes, yeah, super powerful devices. This is a good thing, but it's also a bad thing, because the difference between here is essentially creating performance inequality. The kinds of devices that most of the people in this room are using are here. So when we're testing our own websites, we're kind of testing them on these devices up here, whereas there are large groups, I guess, of people who are sort of in this space here. And we're not kind of seeing how these sites perform on those kinds of devices as well. The other problem, obviously, is, well, as you can see, over time, that's getting worse. Those devices at the bottom aren't moving anywhere. That's kind of the problem. Here's another example with multi-core devices. Still the same problem, essentially. There's a gulf there that's getting larger. So yeah, I mentioned this is the performance inequality gap. Another way to kind of plot this is essentially if we look at the median device at the 50th percentile, that's something like an iPhone 11 or a Samsung Galaxy S20. So 50% of people have those devices, they have a good experience. Even at the 75th percentile, those devices are, the performance of those devices and the experience you get as a user is still okay. And that's something like a Moto E13, which is sort of on that graph still. Or an Apple iPhone 6. Does anyone have an Apple iPhone 6 kind of buried in a drawer somewhere? Maybe it might be worth kind of digging that one out and using it and seeing what the performance is like. But the real problem lies in this area here. So this is 25% of people. So, this side of the room, or 1 in 4 people is another way of looking at that, have honestly a pretty terrible experience with most websites. It's awful. And this is kind of the reason why this stuff's really important. Another thing to look at is networks. So, cool, 4G is sort of a miracle in terms of this sort of thing, and it's widely available now. There's been a huge change in India in particular in terms of 4G coverage. They've had a huge rollout there. So that's made a huge change in terms of the speed of networks. You can see, for example, here, this is your time to first byte budget, right? So if you're on a 3G network, your entire budget is blown just loading the web page, getting that first byte back. So these networks here are a bit of a miracle for this sort of thing. But this doesn't really also tell the complete story, because there's a huge difference between what actual network speed you get. Even if these are both 4G, these are the speeds that you're looking at. This is cities in the United States. This is all I could get the data for, but you can imagine a similar story for cities in Australia, like regional towns versus Melbourne and Sydney, for example. That's a huge difference. Similarly for network latency, which plays a huge impact on time to first byte, you get a similar problem. Yeah, 35% less. Maybe that's the wrong number. It's another way of looking at it is almost 3 times as bad in Anchorage than it is in Texas. Another really interesting thing as well is performance is situational. So this is a talk by Alex Russell, who talks pretty deeply on this particular topic. He had this interesting slide in his presentation where he took this device. This was a Nexus 5X, so this was a little while ago, but he ran this motion mark test on here, which is quite a heavy graphics intensive test on a mobile device. He ran it once, and then he got an ice block out of the fridge and sat it underneath the device and ran the test again, and it was 15% faster. So you can imagine, like we all know already, I'm from Perth, so we get a lot of 45-degree days. If you're outside on a really hot day, that actually could be the opposite, right? You could get 15% worse performance if you're already using like a really old device, 15% worse on top of that, just because you're outside on a hot day. Or in another example, talking more about networks, if you're going through a tunnel, or if you've just got bad coverage, if you're in a region somewhere, or you're sort of on the edge of some sort of coverage, you're on the Optus network maybe, then that's also going to impact your performance, and that's situational, right? I'm doing my best here with this HDMI cable. It doesn't really want to go. All right. So this is where we need real user monitoring, right? Because the only way that we can see how this performance goes, how this performance happens or manifests in the real world, is to get it directly from our real users. So essentially, real user monitoring is capturing performance metrics directly from the device. That allows us to actually factor in all of these things, the differences in network speed and device performance and all sorts of other things. One of the ways we can do that is the Chrome User Experience Report. Who's seen this one before? Ah, no one put their hand up. Oh, yeah, one person at the back. All right. This one is basically the way this is generated is, you know how people who maybe don't like Chrome all that much complain about how Chrome does all this tracking. This is one of the things it's doing constantly in the background. On every website you go to, it does this anonymized, but on every website it go to, the entire time you're browsing on mobile devices or on desktop devices, it's sending these metrics back to Google. And then once every month, they produce this report. It does, yeah, like I said, it does it all anonymized, and you don't get this report if you've got a website that only has 1,000 hits a month, for example. But yeah, you can track this for most pages on the web. This is where that data is going. Cool thing about this is it's free, publicly available data, publicly available real user monitoring data. So that's awesome. I would say it's a bit of a frustrating setup to configure. You need to get Google Data Studio, and then it'll generate a report, so you get a spreadsheet, and then there's another button where it generates the report, and then if you want to, you can set it up to send an email once a month. It's also delayed, so yeah, once a month's a pretty long turnaround. It's actually, the turnaround itself is maybe 2 months, because it gives you the month of January about halfway through February. So if you make a change and that change has a negative impact on performance, you won't know that for potentially 45 days. That's not ideal. And it also tracks only Google Chrome devices, so you don't get any information from Safari-based browsers or anything like that. Another thing that's good to use is this Core Web Vitals checker. So this is also made by Calibre. And essentially it just pulls the data from the Chrome User Experience Report. It's just a lot easier to do. You don't need to configure anything, so that's nice. I can go and access that data on demand. I could go and run a test right now, not have to do any configuration. But then, of course, it has the same upsides and downsides as the Chrome User Experience Report, so it's only Chrome devices, and it's a month and a half delayed. This isn't the end of my talk, don't worry. I should probably say at this point, DDD doesn't happen without the sponsors. It's a great conference that I've hugely benefited from. I get to speak at a lot of DDDs, and I've probably, well, hopefully you guys invite me back after this, but I've decided to throw all of the sponsors under the bus and do a leaderboard, because you can access Web Vitals for any website in the world that you want, so I might as well just put them all on a leaderboard and tell you which one's the best. I should say before I do this that if you get a bad score, it's not, I'm not trying to be mean or anything like this. This is an opportunity for improvement, right? This is something that you can take. It's a nugget of information you can take back to work on Monday and say, hey, look, this is something that we can fix, and we know what the benefits are, right? You can go back to work on Monday and look really good to your boss. So yeah, I'm going to track these metrics by LCP because anecdotally that's kind of the most important score generally. So yeah, ordered by LCP. I'm just going to throw all of the lower scores up on there. So there's some interesting results there. A couple of websites. Oh geez, this is terrible. A couple of websites there at the bottom don't have any results. That's because, like I said before, if you get under 1,000 hits a month, then Google won't actually generate, in the sake of anonymizing the traffic. Oh my God. They won't actually generate a report for you, keeping it anonymous. Those lower results there, yeah, like I said, opportunity for improvement. Only one site got a kind of a bad score for CLS, which is the one with the interstitials, the modals and pop-ups and stuff like that. Everyone else has done a pretty good job there. So yeah, not a lot of annoying pop-ups on sites except for the Insight crew. Hopefully that's going to work. Before I do the last three, does anyone want to guess what the number one might be? GitHub? That's a really good guess, actually. Smart guess. GitHub's third, but they do have a really, really good LCP score. And the difference isn't a huge amount. But yeah, the number one sponsor is Liberty. Liberty, though, do have a high CLS in the end, though, so they must have some sort of pop-up on there. Yeah, like I said, GitHub's a good guess. Does anyone want to guess why GitHub is such a high score? Like in other cities I've done this, GitHub was number one. Any guesses? Sorry, what was that? Server-side rendering, yes, that's true. Location? I think their servers would be based in the US, but it's actually, because this is real user metrics, most of the people browsing this are doing it on a desktop. So that's already going to be a much faster device. Also, it's going to be, if you're going to the GitHub website on your phone, it's going to be probably an iPhone because there's a lot of developers here. We're kind of lucky in that we are in a higher income tax bracket most of the time. Cool. All right. So I've told you how to capture these metrics from end user devices. I'm going to go quickly through continuous monitoring now. So yeah, as I said, the problem with a lot of these things is, particularly the Crux report and the Web Vitals checker, is the data in there is delayed by a month and a half. So how can we fix that problem? I don't know. Like, here's my question marks down here. I don't know the solution. But let's figure it out, right? One of the ones that's really interesting is this tool called Request Metrics. When I first did this one in Perth, the guy from this website reached out to me and said, "Hey, have you seen this before?" So yeah, now it's in my slides. This is a great product. It basically tells you this in real time. It's awesome. Going through the positives and negatives, I'd say that yeah, it pretty much solves the problem, right? You get near real-time continuous monitoring of real user metrics, which is exactly what we need. It doesn't do any sampling, so it gives you every single result. And that can actually result in the service itself being pretty expensive. So if we look at the price of this, yeah, it's pretty expensive. That being said, $200 a month for 1 million sessions, if you can increase conversion by 8% by reducing your LCP, you figure out a problem and solve it, then that would pay itself off. So it can be expensive, but it depends on how you look at it. But I wonder, could we build this ourselves? Because it doesn't seem that hard, right? I would actually say that this is probably a stupid idea, so don't do this. But when I first did this, there weren't a lot of options around actually that had real user monitoring. So if we look to all the usual suspects for platforms for observability and stuff like that, this actually wasn't the case 2 years ago when I first did this. So I actually did build it myself, but since then, Datadog, Dynatrace, New Relic, Splunk, and Grafana, and Elastic all have a solution for this. So if you're using any of those, don't build it yourself. Even then, probably don't do it. But I'm going to show you anyway how I did it, just because it's a talk and I want to tell people. So what I did is I built an analytics service. It's a simple Node.js application, and I sent the results of the Chrome Web Vitals and user-centric metrics to this service. And then I used the standard Prometheus and Grafana stack to read those metrics, and I built a dashboard. You can see that dashboard over on the far right. That's tracking, the one on the screen there is time to first byte as well. The way you do that is you use this Web Vitals library. So Google have packaged up the metrics into this really simple to use library. You can just install this, npm install Web Vitals, and you can just get that. So that's pretty cool. I'm going to show you the code too, because the code is simple enough to fit on 2 slides. You just import the library. It gives you methods for each one of those metrics, and those are just basically event listeners. So the moment the metric is captured, you can use that to send metric to your analytics service. In which case, it's essentially a fetch to an endpoint. We just send that data. Navigator.sendBeacon is a bit like fetch, but it's better to use that in this case because your browser, if you're navigating away from a page, which is often when these metrics are captured and recorded, will cancel fetch requests, but it won't cancel these. And this is exactly what it's meant to be used for. And and you just send the data straight there. And this is the server, so this is Node.js code, nice and simple. Use the prom client, that's just Prometheus, and you just create a metric for each one of those when it comes in. I separated them out by line. If you're recording those metrics, you've just got this. This is the analytics endpoint itself, simple Express server. It detects what kind of metric you're recording and then just records that. Trying my best with the screen here. So that's the whole thing. I said it fit on 2 slides, it actually fit on 3, but it's dead simple. The nice thing about building it yourself is you can change the way it works. So if you don't want to use Prometheus and Grafana, you can use anything else. You could use something like S3 and Snowflake. They'll give you more long-term metrics. Prometheus is really great for metrics within the last 24 hours, if you want to kind of track that. But it will throw away old metrics because it kind of wants to run in memory to run as fast as possible. So if you didn't want to use that, if you wanted to be able to record over a longer period of time, you might use an analytics platform, something like this, where it would send the data to Snowflake, to Redshift, some sort of OLAP database. Then you could query over a much longer period of time, and you could do interesting queries with a lot more dimensions like device type and location. Cool, so in terms of building it yourself, we solve all the same problems as request metrics. We get near real-time continuous monitoring. We're just using all free open source tooling. I haven't really had to write anything myself except for the Express server. I'm just gluing bits together, really. It's almost certainly a bad idea. If you've got something that you can just use out of the box that comes with your current analytics tooling like Datadog or Dynatrace, use that instead. Don't do this because you're going to have to maintain this. You've got an ongoing maintenance cost as well. And for that reason, I'm not going to give this talk again. I think most of the platforms, the analytics platforms that are out there are kind of adopting this. They have solutions for real user monitoring now. Cool, so we ticked off all our goals. We have user-centric performance, we're capturing metrics from end user devices, and we're doing it continuously. So we're able to track metrics over time. So this is the end of my talk. I just want to kind of end on a positive note because I kind of, I guess maybe towards the middle of the talk I was a bit negative about sort of the way performance is going. But because of the Web Performance Working Group, we've actually sort of seen a lot of positive change over time. This is the number of sites that, according to the Crux report, pass Core Web Vitals. And you can see that that number's going up. For mobile devices in 2020, that number was under 20%, which is appalling. The Chrome User Experience Report counts a website as having passed if the P75, the 75th percentile, passes the test. So this is good. Over time, this is going up. This is ending on a positive note. The other thing I'd say that I think is really interesting about this is the concept of user-centric web performance, user-centric performance in general. I've talked a lot about the web here, but I work a lot more now in mobile apps, and there isn't an equivalent of something like this in mobile apps, not as far as I know yet. So I think there's something really interesting in that as well, like taking metrics that are much more centered around the experience for the user, recording those metrics, I think has resulted in a massive improvement over time in this sort of thing. Cool. End of my talk. So here's a bunch of resources. This is available on my website as well. So if you want to click any of these and get more information, you can find it there. Again, thank you to the sponsors. Hopefully, I do actually get invited back after dishing on them all. And yeah, play the sponsor bingo and you can win. Also, if you can get it to work, give feedback as well, not just to me, but to all of the presenters here. Keep in mind that it was mentioned at the start, but this is the DDD platform is something that is really beneficial to first-time speakers. If you get the chance to speak, that was me a couple of years ago. Getting that feedback is really, really important. So make sure you give feedback to each one of the speakers as you see it, because it can really help them grow and then hopefully come back again as well. Thank you very much.